Spy, which is a combination of Buckeye and iSpy. Our goal is to create a data set of a publicly accessible open image data set of images around the Ohio State University campus, make that open and accessible for enterprises, research, and recreational purposes. Our implementation of that goal is to create a game, a location-based game that's built around 3 different technologies. We've got Google Home, Amazon Alexa, Android, and then everything runs on the back end and uses Google Cloud Vision API to actually feature extract and make other insights off of that, and to group all of the photos into individual buckets. Reach searchers, businesses, recreational people can go in and view those. So we'll start off with the demo of the app. Any Google-enabled phone can actually just talk to it. Press and hold the home button. Talk to Buckeye Seek. Thank you. Talk to Buckeye Spy.
All right, getting the test version of Buckeye Spy.
Welcome to Buckeye Spy. Are you ready to play?
Yes.
Your current target location is the Ark. Go there and say, "Okay, Google, tell Buckeye Spy I'm here." Happy hunting.
So you then go to the Ark, and then you open up the app and you say, "Tell Buckeye Spy I'm here."
Sure, here's the test version of Buckeye Spy.
To see if you found the Ark, I'll just need to get your street address.
To get permission.
Is that okay?
Absolutely.
You are 0.98 miles away from the Ark. Get closer and try again.
So we're too far away right now to actually be there, so we're not going to get any points for that. If we went out to the Ark and we got it, I was going to be able to demo it off of my phone, but we can't right now. It would tell you that you're here, you get some points, and then it prompts you to open up the Android app and take a photo of it. This is where we get the accessible data. So if they get more points for uploading an image than they do for just visiting. And then Drew's going to take it over with the Android app.
For the Android app, you guys can't really see my phone. It's kind of small, isn't it? But you can log in. I made a nice little wallpaper on the back. You sign in with Google, and that also signs you into our Fire database in the back. I'm going to just log in as my user. After that, you just allow it access to use your camera. It'll pop up a nice, you guys can't see anything. Pops up a nice little camera thing. You can take a picture, and then it'll tell you that it's saved. Then you can upload the picture, and that uploads it to the database.
So the database we used was this through the Google Cloud platform, and so we had like about 5,000 images of Ohio State already in the database. And so when an image is uploaded, so for instance, we have an image of the Union that somebody could take. As soon as an image is uploaded, we actually have a program that goes in the back end and begins to parse through that image, and so then we'll get and really leverage the Google Cloud Vision API. And so from there, they have a set of labels that we can gather, and so it's a set of keywords that explain the image, and then it can also run web entries to see more of like an image recognition search on like Google's full database. And so it'll try to figure out what that image is based on similar looking images. Moving forward, our goal was to take that main web entry description and then create a bucket or a folder where we could then move that file. And so as soon as we get the most probable keyword, we put that image in that bucket, and so we have a fully organized and then full database of everywhere in Ohio State. And so you can see here, this is the Vision API, and here is some of the output. And so it says we have 10 different web entries, the most probable being the Ohio Union. It also has tags for Ohio State University and University. But even more so, we can also grab all of the different labels. And so it knows that it's a building. It could be a neighborhood or mixed use, corporate headquarters. And so these are all data points that we can gather and then with more time use for even more insights to learn more about OSU.
Michael's our most fresh coder. You want to kind of talk about what you learned through the process?
Yeah, so this was actually my first hackathon that I've ever been to. And So I never worked with APIs or JavaScript too much, and this entire project sort of featured NodeJS communicating with Google Vision's API. So for the most part, it was a learning experience, but having Pat and Jared and Drew to work with, but Drew's more on the app side of it, it was an easy way to get into machine learning for me, never having done that before either. And I was actually able to make an Alexa intent, which was very cool. It was the first time working with that also in JavaScript. So overall, it was a great learning experience, and happy I made these connections too.
I learned more about Fire. Good job, guys.
What motivated you to be more on the user side of the AI rather than the building side of AI?
What do you mean by user?
Like you used Vision API from Google, right? You used AI to build your solution. So what motivated you to go more that direction than actually like finding a data set and building something like that?
Google has the best and most well-formed artificial intelligence out there right now. So rather than reinventing the wheel and try to create a feature extraction tool, Google already has a great one that you can plug into just like electricity or just like water. I consider AI at this point like a utility. And rather than going and recreating the wheel, we are trying to just plug different artificial intelligence solutions together and to use that to then create new things that weren't even possible yesterday. We could have,
And then also, for me it was really interesting because I'm really interested in the technical aspects behind it, but this was a really tangible example of like using machine learning, and it was a very applicable to like industry. And so I really liked that because it gave me something that was really straightforward to understand.
Yeah, based on Google Vision API, what kind of information you can extract from your uploaded filter?
I'm sorry, can you repeat that?
What kind of information you can extract from the filter you upload based on Google
Information.
Yeah. You just show the.
Hold on, like a building, like.
So when you upload the filter that it's taken photo from Ohio Union, the Google API can identify the Ohio Union.
Yes. So what it does, it sends you a JSON file of all the different kinds of attributes that have, so here's the example.
This is the demo on the website.
And so it tells you that it is the Ohio Union, it'll tell you information on the kinds of colors. And
So
then,
that photo is taken by yourself, right?
Found it on Google. Just search for Ohio Union.
No. I'm asking, you take a photo by yourself.
Yes.
And then identify this photo by using Google API.
Alright, we gotta cut you guys off.
Ohio.
Next group you guys can set up.
I'm still filming. Thank you.